DNA. It's the blueprint of how to build a living being. You see, the key is in the simplicity. Small changes in the DNA structure can have a huge ripple effect on the overall design. Your network's DNA works the same way. A small change will result in either huge benefit or massive burden. That's why the world's best networks start with VSS as the base of their overall network DNA. Cisco's Virtual Switching System is a clustering technology that turns two physical 6500 chassis into a single, logically managed powerhouse of redundancy. No, there's no magic in this. It's all in the engineering. From the control plane and the management plane perspective, this means a pair of VSS-enabled switches will reduce complexity and management overhead by as much as 50%. As leading edge as this may sound, it's very well established and widely deployed by a lot of customers. The feature set's consistent across platforms, including line cards, service modules, even the latest supervisor. This translates to a single config file, a single interface to manage both devices. You could even use the CLI, SNMP, or both. What's that? Worried about configurations or policy changes? It's not a problem. Just update your policy and apply it. With VSS, any update is automatically synchronized between the two switches. This makes error-prone manual synchronization a relic from the past. Now, on the network side, this is an active-active technology. Both of these 6500s are forwarding traffic and all the links are active as well. We're not playing games with the redundancy here. There's no crazy VLAN load balancing schemes using first hop redundancy protocol, multiple IPs per subnet spanning tree in this design. VSS automatically synchronizes the ARP and MAC tables between the 6500s, which eliminates asymmetric routing and the unicast flooding that it always brings with it. But the best part? Your convergence time in a failure is under 200 milliseconds. This means that in the time it took me to say this, your network could have failed and recovered over 30 times. A couple other cool things about VSS in this design worth pointing out. You see these links between the chassis? That's our virtual switch link, or VSL. This link carries normal data and control plane communication between the switches. VSL can be configured on up to 8 10 gigabyte links in any combination of line card or supervisor ports. Although I do find that 2 links work fine for most, your distance is really only limited by the optics installed. Questions? Of course, spanning tree, of course. Loop-free topology is handled with MEC, or multi-chassis ether channel. MEC can connect any device that supports ether channel and can be configured to support either port aggregation protocol or link aggregation protocol. VSS will also balance the traffic across each chassis independently to keep all links active. Listen, VSS trumps the weaknesses in traditional gateway redundancy protocols like VRRP. The days of multiple IP addresses, CPU-intensive protocols, and complexity. I mean, come on, tracking interfaces, anyone? A convergence time that gets worse the more you scale your network. Those days are over. The benefits of the virtual switching system in today's real-time networks are tremendous. A simplified topology, management, plus a doubling of your uplink bandwidth with existing gear all add up to simply superior technology.